FluoRender tutorials. Visualizing multi-channel data. Part 1. Load data. Double-click the FluoRender icon to launch FluoRender. Click Open Volume to load volume data. Select one TIFF file and click Open. One volume channel is loaded. You can also drag and drop files into FluoRender. Open the other two channels using drag and drop. Deleting a channel from the Workspace panel only removes it from the render view. Data are deleted from FluoRender in the Datasets panel. Use the single X button to delete selected volume. Use the double X button to delete all volumes. Data deleted from FluoRender can be reloaded. You can choose multiple files in the same folder to load all of them. Part 2. Render View User Interactions. To rotate the view, hold down the left mouse button and drag. To pan the view, hold down the middle mouse button and drag. To zoom the view, hold down the right mouse button and drag. Reset view rotation using the Rotation Reset button. Reset panning using the crosshair button. Reset zooming using the Zoom Reset button. You can also rotate using the rotation sliders. Drag the slider control off its center position to rotate along an axis. The farther the control goes, the faster the view rotates. You can also set the slider to control rotation angle directly. The rotation angle along each axis is set directly by the position of the slider control. Zoom value can be set by the zoom slider directly as well. Drag the slider or type in a zoom value to quickly set a zoom view. You can adjust the perspective angle with a slider control. Increasing the perspective angle can enhance 3D perception, but the object may look distorted. Reset rotation and perspective angle. You can turn on the display of a scale bar. Click it twice to show its length value as well. The zoom value can be calculated in two modes. In the data-dependent mode, the zoom value is displayed based on the amount of screen pixels to render the data. The zoom value will always be 100 when you click the 1:1 button. In the view-dependent mode, the zoom value is displayed as the size of the data relative to the render view size. The zoom value when the 1:1 button is clicked can vary depending on your screen size. Also notice that the length of the scale bar changes depending on the zoom value. Part 3. Visualization adjustments for a single channel. Click a channel in the Workspace panel to select it. Double-click to toggle its display on and off. Select the blue channel to change its color. We can use the color button to set a primary color. Double-click the color values to select the text. Press a keyboard button to set a color, for example, R for red, G for green, B for blue, and W for white. Use the settings in the Property panel to adjust the visualization of the selected channel. Gamma changes the nonlinear contrast of the intensity values. Increase gamma to brighten low-intensity voxels. Decrease gamma to suppress low-intensity voxels. Increase the value of boundary extraction to show voxels with high gradient magnitudes, which are usually structure boundaries. Lower the saturation value brightens the data, as it determines the highest, or saturated intensity value. Use the low threshold setting to cut off low-intensity signals. Use the high threshold setting to cut off high-intensity signals. Use luminance to adjust the overall brightness. Click the Shadow button to enable it and adjust the shadow intensity value using the slider. Adjust the alpha value to change the opacity of voxels. Decrease the alpha value to make the data transparent. The sample rate value determines the rendering quality. Decrease this value for better interaction speed. Click the Shading button to enable shading. Shading is a lighting effect that helps visualize fine details. Adjust the shading value for different appearances of the data. Click the MIP button to enable the maximum intensity projection. The MIP mode shows high-intensity signals clearly, which can otherwise get occluded for structures inside an object. Use the spacing values to set the voxel size of the data. Notice how the scale of the data is influenced by setting these values. The correct Z proportions can be achieved by setting the spacing values if they are not read from the file correctly. Click Color Map to enable a color map of intensity values. A series of color maps can be selected, such as rainbow, reverse rainbow, hot, cool, and diverging. Click Shading and Shadow to enable lighting effects in MIP mode. These lighting effects are rendered separately and overlaid on top of the MIP rendering. Let's set the color map to rainbow and disable MIP. Instead of mapping colors to intensity, we can also map them to the Z, or depth coordinates. It allows distinguishing structures from different depth levels. Click the Depth Attenuation button to attenuate brightness along the depth of a viewing direction. Use the slider to adjust the attenuation strength. Depth attenuation enhances the perception of 3D depth. The volume property settings can be reset to the defaults by clicking the Reset button in the Property panel. Part 4. Visualization adjustments for multiple channels. Enable all 3 channels of this sample dataset. Use the buttons at the top of Render View to change channel intermixing modes. The first mode is called Layered. It renders each channel and layers them one on top of another. The layering order can be changed in the Workspace panel. We drag the Y channel to the top in the Workspace panel. The Y channel is also always rendered on top in the Render View. Similarly, we can set the red or green channel on top in the Layered mode. The second channel intermixing mode is called Depth. It rendered channels based on their 3D relationships. However, the Y channel includes most of the other 2 channels. We can switch to the third mode, called the Composite. It renders each channel and combines the results by colors, so that channels of different colors can be distinguished. Let's switch to the depth mode again and select the white channel. We can use clipping planes to hide the occluding part of the channel and reveal underlying structures. Use the sliders in the clipping plane panel to set the positions of 6 clipping planes. The clipping planes are color-coded in the clipping plane panel and the render view. Use the Reset button in the clipping plane panel to reset. We can apply clipping on X, Y, and Z axes from both directions. Clipping planes can be used to reveal occluded structures from the selected channel or other channels. We can synchronize the clipping planes for all channels by clicking the Synchronize button in the panel. Settings to clipping planes of one channel are also applied to other channels. We can examine a transverse section of all channels using synchronized clipping planes. By default, clipping planes are only shown when the mouse cursor moves into the clipping plane panel. We can click the Hold button to always show the clipping planes. Clipping planes can be also shown in several modes, such as the wireframe mode, the low opacity mode, the backplane only mode, and the backplane only mode with color-coded planes. Click these buttons again to reset clipping plane display. We can use the settings in the Output Adjustment panel to adjust the rendered results as 2D images. The output luminance changes the brightness of the result. The output gamma changes the contrast of the result. The output equalization changes the proportion of high and low intensity pixels with regard to local contrast. Use these settings for good visualization results. Output adjustments are calculated in the image space using floating point numbers to preserve information from original data. For best channel intermixing clarity, drag the white channel down to create a new group. Switch to the layered channel intermixing mode and select the red channel from the first group. We can enable the depth mode within a group by clicking the Depth Mode button in the Property panel. Now, the red and green channels are in the depth mode. They are in one group layered on top of the white channel. The white channel is used as background, which cannot occlude the channels from the other group. Part 5. Projects. All settings can be saved in a project file for later use. Click Save Project. In the dialog window, choose a folder and project name for saving. Click Save to save the project. Close and launch FluoRender again. Click Open Project to open the saved project file. The previously loaded data are restored with all the settings that we applied in the tutorial.